I want to go through some things. So this is Thursday. Can you guys see the board, or is that better? Or it doesn't matter? Nobody's going to say anything. So I'm going to assume, please.
I can see
go ahead.
it. I can
you can see the board, okay?
Yeah.
You can see the writing. You don't have to write this down. This is a reminder to me of questions people have been asking me, and to go over it. So the folder for next week appeared this morning. I'm going to make it so on Thursdays is when it will typically show up. So all the stuff you need for next week is there. There's nothing you need this week. You guys should have already had that in week 1. A couple questions that came up before class. There is on the Blackboard, and this is week 1, so we're all learning how to do this. And please ask if you're not sure, because other people have asked the question also. There is a link in the upper left-hand corner to my YouTube channel. I apologize, I'm mirrored, or else all my writing is backwards, so I am holding up my left hand. My YouTube channel, you have to click on that tab, and it gives you a link, and you go into our Chem 151 playlist. So there is the discussion on scientific notation and significant digits. It's like a half-hour video, and I'm dressed as Tinkerbell. And so that is for you to watch. I will discuss scientific notation a little bit today as I do the conversions, the unit conversions. I also posted our lecture from Tuesday. And so today's what I'm recording right now, I will also post. When I leave this class, I am actually in another class. So sometimes Tuesday stuff and Thursday stuff won't get posted until the evening when I finally have a break. If you're still having trouble getting to the YouTube, you'll find everybody ends up saying they really like that it's on YouTube. You don't have to go through Blackboard once you found the channel. And so it's only our playlist you need to worry about. There's a playlist for each one of my classes, and I have 7 classes, so you don't want to go there. There is also on there the link from your lab. There's like a 45-minute PowerPoint video where I talk about the atomic history. So the Zoom office hours are there, and I do from now on Tuesday and Thursday, this link will open at 9 a.m. So you can come in to ask questions. At 10 o'clock, I will start videotaping for lecture. And then when I get done on Thursday, I will stay on as an office hour until just before 1 o'clock. On Tuesday, I will stay on just before noon. I have a class on Tuesdays that starts at noon. I also, so this is, it tells you this on the syllabus. I also, on Thursday, there is on Tuesday and Thursday, this is an extra office hour from 6 to 7 p.m. It's a different link, and it's there on our page, because I know there's several people, especially on Thursday, that work during this time. You can always come to the office hour, and people want it a little bit earlier, talk to me and we can negotiate that. And if it's also really nice, what my classes in the past did was they often came to the office hour because other students were there, and I can actually put you in rooms in the Zoom. It's actually a cool feature. I can send you to your room is basically what I do. And other people from our class will be in there so you can work on stuff together. So why that's important on Thursday, my office hours, is your labs are due on Thursday. And it is an 11:59 p.m. due time, but I go to bed long before that. So if you have questions, I would work on it either that you have it done Thursday at this time so you can ask questions during my office hours, or in the evening. The lab has 4 pages, and then you need to scan it all as one document and upload it. So if you don't know how to do that, please talk to me during office hours. I can send you a link. Your phones all have the capability to be a scanner if you don't have a scanner. If you can't figure out how to do it today, just take pictures and upload those, but we need to all learn how to scan as one document. it's a huge difference for me. I have 75 students or something between my 3 classes. All right, I talked about this. This is for everybody watching at home. I am going to let you do take-home quizzes through the first midterm, and then I'm hoping to keep doing it that way. So as long as you guys all stay honest and keep your heart open, we will do take-home quizzes. So the quizzes won't appear until Tuesday. You will have to take them on Tuesday. You take them on your own time. Your study sets, though, so SS is for study set. I think I wrote all this in Blackboard. I got rid of my initial announcement and put this all in the announcement. But study set 1, every study set is due Tuesday at 10 a.m. Your study set is graded, and I'll go through this again Tuesday, that you did it. It's not necessarily perfect, but you did everything. And you'll upload it onto Blackboard. So you don't email it to me. You have to learn how to upload onto Blackboard. And again, I realize this first week or 2 is all of us learning how to do that, because a lot of people are new to that. And then at 10 o'clock during Zoom, I will go over it so that you will be able to at home correct it on your piece of paper or however you did it. So you will have the right answers. So you will get a 5 by turning it in and also being here on Tuesday. And then the quiz will appear Tuesday morning, and you can just do it after class, because often as I'm going over the homework, that will point out things that you are like, oh, so yeah, you get 1 go at the quiz and uploading it. And I think I made it due also at 11:59 on Tuesdays. The quizzes are going to take you anywhere from 10 to 30 minutes. So yeah. All right, lectures. I'm going to be lecturing. That gives me then more time on Tuesday. I've split my weekly lecture up. So on Tuesday, I will go through the study set, and then I'll probably be doing about a 1-hour lecture on each Tuesday and Thursday. And then the last comment is there was a bonus email that I sent to all of you on Sunday. And I asked you to reply to it and tell me the significance. I asked basically, why did I not number with 1, 2, 3, 4? Why did me as a chemist, if I go out of focus, let me know. We have a periodic table. Chemists count different than the rest of the world and the planet, teachers, whatever. So it's an easy bonus point. Get all the bonus points you can. Never, always do a bonus point. Is there any questions on stuff? So the other question somebody asked me was about if there was anything more you needed today. We're going to finish the lecture notes. And again, the first page we went through. If you didn't print, please realize you can just write down on notebook paper. That is fine. You can always go back and watch the video once it's there if you have stuff you want to fill in. The second page has Tinkerbell on it. It says chemistry math. It has, you can connect the dots. That's the extra video that you have to watch. There's another Tinkerbell one up there. We're going to go through these last 2 pages. So there's a page that says metric, and that's the page I'm on. And I have to find my eraser. So the lecture, your homework and your quiz is over those first 2 pages. The very last page is practice, and so I'll have time. We'll do this after I go through the math. So this math, the unit conversions, is what I'm going to talk about now. If my pen, if you can't see it, please let me know and I can find another pen. And they seem to run out of ink on me. All right. This is not on the first quiz or the first homework set. A couple of people have asked me, they said, I had trouble trying to do that, and that's because I hadn't gone over it yet. This is what we do next week. This is all for the lab that's there. I'm going to do just like a half-hour, 45-minute intro here, And then Tuesday's lecture is all this. We're going to do more practice. So just give yourself permission to be like, okay, I just got to get the lab in. I try to be consistent through the term, so you'll get in the pattern. It usually takes the first week or two to get the pattern down. As I go through this, I will also review some of the metric stuff. But what unit conversions are is this idea that there's 12 inches in 1 foot. And what that means, we're going to write them as fractions. So we can write it, there's 12 inches in a foot, or we can write it, and you don't have to write this down, you can just listen. There's 1 foot has 12 inches. So we write it one way or the other. When we do the math, which we'll do in a moment with the gnome, we'll know which way to write it. These fractions, the thing that is interesting is this is actually equal to 1. And you're probably looking at it going, that's not equal to 1. That's equal to 12. 12 divided by 1 is 12. And the key is there's units. Chemists work with units. Because there's units, this is not 12, this is 12 inches, and 12 inches is 1 foot. So these factors, they're called factors. That's why you'll usually hear me call it factor label, is these are called factors. So when we worked with metric, which was a chart at the top of the page, just a reminder how that chart works, because your test you're going to be doing right at home. The test will be during this time on Tuesdays, and they have a time limit. So they're on your syllabus what days they are. It's just the quizzes that you get the whole day to do them. So that chart, you have a chart just like it on the lab. How the chart works, let's say we're doing kilo. So it will say K is 10 to the third. And then you have M. So K is kilo. And little m is milli. And milli is 10 to the negative 3. So what that means, if we look at milli, and I'm pretty sure I talked about this the other day, is that 1 millimeter or 1 milligram or 1 milliliter is equal to 10 to negative 3 meters. Or when we put it into factor label, if we do a factor, we would say 1 millimeter, 10 to negative 3 meters. Or we can flip it. But how it always works, tell me if you can't see the red. One of the prefix, so 1 kilogram, 1 picogram, 1 zettabyte is always equal to 10 to the power of the base unit. And again, the base unit can be grams, it can be seconds, it can be liters, it can be meters, it can be bytes like on your computer, it can be pascals. We're going to see that as I go through the factor label here. So, questions. All right, so we're going to walk through this, my eraser. Oh, a couple more things before I get started. There are some, the metric, again, that's how these metric conversions will work. There are some US conversions. Yeah, I don't know where my good blue pen is. And so what you're going to want to do for midterms is have 1 page of your notes organized so you can follow it. Same with going through study sets and things like that. So those metric charts, you can pick which one you like. You can make one of your own. But if we go between US units, right, this is doing metric. The ones you should be familiar with, and again, you do not need to write this down if you know these. There are several students who are from other countries and they don't know these. So these are going to be the ones that we run into. So you might want to write these down. So 12 inches to 1 foot, 3 feet equal 1 yard. When you abbreviate units, you have to use the correct abbreviation. You don't get to make up one. This is one that many people forget, so you might want to all write it down. There's 5,280 feet in 1 mile. And again, if you can't see me or there's a weird glare, just let me know. So those are all distance. There are 16 ounces to 1 pound. So that's LB. I write it in cursive because otherwise you think I said 1B. And there's 2 pints to a quart. There are 4 quarts in a gallon. So this is actually a great time to remind you, today's October 1st. I hope if you haven't, you go to my YouTube channel. There is a video about Healthy Change October, and it's a 30-minute video, and then you can decide, yeah, I'm going to make a healthy change. There's a couple of people have emailed me, and then at the end of the month, there'll be a place where you can upload what you did and how it went and stuff, or you can talk to me later about that. You're going to see me using these conversions. 32 fluid ounces, that's a Z, equals 1 quart. Now, if you go on Google, they'll have conversions between everything possible. Because of the environment that we're in, you guys are going to be limited to certain conversions. And so that way I can see that you have the methodology down. Once we get into the periodic table, we move completely only using pretty much the metric system. And what we're doing is we're going to learn this format. Some of you may have learned it in a high school class or in a math class, but it's so when we do the math with the periodic table, we have this system down. All right, so we're going to talk about the gnome, and I'm going to be a gnome. In case you don't know what a gnome is, so there's my gnome hat. I have to remove my headphones. And so I asked myself, I got tired of writing boring questions, so I write stories. You can ignore my stories. What you need is the number. So a gnome, the G does not stand for gnome, it stands for gram. Gram is just a G. GR actually means something different. And so turns out that's how much a gnome weighs, and I want to know how many ounces it is. So we're going to do this with conversions. Now, some of you have learned how to do it. If you worked on the metric, like Christian was here earlier, and you can do it where you say, okay, I'm going to multiply by these fractions like that. You can do it with parentheses. Again, don't write this part down. You kind of have to find your own way. How you're going to see me do it on the board is actually a really great teaching method, and you can use it that way also. But you're going to have to do your problem solving in this format. When you're initially learning it, a lot of students struggle with it, but once you get it, which will be by the end of next week, it just starts rocking, and it makes everything as we go through the term much smoother. So I do what I call our boxes, and only 1 unit per box. And that will become important like when we get to number 3. And what you do is you take, it's called unit conversions, because you take this unit, the grams, and you bring it down here. Not the number, just the unit. And I'm trying to change from metric to the US units. They're not actually called US units, they're called imperial units, because that's what the empire used, right? So I'm going to change grams to pounds. And at the top of that page in the notes, it will be on the top of, for those of you in 151, top of the page in the lab, top of the page in the next study set, I think study set 2. There are certain US symmetric conversions that we're going to use. There is a conversion from grams straight to ounces, and that's wonderful. But I'm trying to teach you the methodology. So we're going to change grams to pounds, and then we're going to change pounds to ounces. So you're going to have to use, you're going to be limited when you change between US and metric to my conversions. And my conversions are awesome. So what I said is that 1 pound is 454 grams. So I think it says at the top of the page, it says 454 grams equals 1 pound. So when I plug it in, why the 454 is in the denominator on the bottom is because that's how the unit cancels out. Now I didn't do anything, I haven't touched my calculator yet. This unit cancels, not the number, just the unit. Now I look at this piece. This piece, each one of these vertical fractions has to hold true by itself. So there are 16 ounces to 1 pound. One of the things you'll notice as I do it, I always put my units in and then I bring the numbers in. So keep that in mind. It just takes practice. We get a lot of practice over the next week. So by this time next week, you'll all be professionals at it. And I got to my unit. Now you get your calculator out. So there are different ways you can do this on your calculator. There is one correct answer. You can punch across the top, get a number, punch across the bottom, get a number, and then bring them together. You can do the thing where you use parentheses and you do all those parentheses on your calculator. To me, that's a lot of work. So I'm a chemist. And one of the things that chemists and engineers do, and in all honesty, humans in general, is we want to be as efficient as we can be. When I was your age, we didn't have calculators with parentheses. So that's probably why I did it this way. You don't have to punch it in your calculator this way. What I care is that you can do it so that you know what you're doing. And again, that's why I have all these office hours. And so it's having good study habits. So great. All right. Well, I know I also added another office hour. So on Saturday mornings, I actually teach a class. And so I posted it under the Zoom links. Saturday mornings from 10 to 11, I will keep my Zoom link open from the other class when they leave. So if you want to come, some people, they have in the past been popular. Some people are like, yeah, Saturday morning works for me. So my other class actually has an assignment due Saturday night, and I put it there for your class because I know some people have told me they work during the week. So you're welcome to come. Just be patient if you show up, because sometimes I have to wait for the class to finish. All right, how I punch this in my calculator. What I find is some people love this and some people are like, I didn't like it. Find the way that works for you. So 307.65, I ignore the ones, because if you multiply or divide by 1, you have the same number. If my number is in the denominator, I say I'm going to divide now by the 454. If my number is in the numerator, I say, okay, I'm going to multiply. So that's all I do when I put it in my calculator, is I just take this number, I divide, I multiply, and then I hit equal. And I put the squigglies because it's always an approximate. I do not need to see this. And you can put it if that's something that helps you, but you're going to punch it in your calculator. I actually did it before class today, and you'll get an answer. And we're going to talk about significant digits really briefly. Your answer is this whole page, these 4 questions that we're going to do today, they all end up with 3 digits. So you'll have to round your calculator. The next digit was a 2, so you just drop it. You don't need to write the whole number from your calculator. I just need those 3 digits. So for Sig Figs, and again, you'll want to watch the video about Tinkerbell, and we have some homework next week that has Sig Figs, and so we'll refine it and stuff with that. The 2 things that determine Sig Figs are anything that you measure And those are the ones that are given to you in the problem. So my grams, this has 5 digits. The zeros in between, so it counts. And anytime you go between US to metric. Now, the 4 that I give you on top of this page and everything that I give you, why I like my conversions better than Google is I was consistent with my conversions. If you look at them, they all have 3 Sig Figs. When you go on Google, sometimes they give you 2. They actually like to give you 6 sometimes. They give you crazy number of Sig Figs. All right, this is exact. When you're within US, when you're within the metric system, they are exact numbers, and that is because these are what are known as a definition. There are 12 inches in a foot. That's how they defined. That wasn't actually the original way. An inch was originally a sun, your finger knuckle. In Chinese medicine, that's how they still measure. And the foot was the emperor's foot, and it changed every time there was a new emperor. But now it became this definition, so you don't change that. All right. That's our first one. I just always pause in case somebody has a question. If you have a question, please ask. Otherwise, I'm going to erase and move on to the next example. And we'll do the practice with the Sig Figs as we go through these. So this is a real story. I wanted to make my questions more interesting than saying 307 grams is how many ounces. So I said, how much does the gnome weigh? This was like 10 years ago. And I got this hit that the Large Hadron Collider, which is where all the physicists work, where they're like finding new particles, subatomic particles, Bose-Higgs particle, and at CERN, they actually asked this question, and they sent this gnome around the globe, and he does actually, to show the globe is not a perfect sphere. And so I then asked myself, how tall is a gnome? And the answer Google gave me was gnomes are knee high. So I measured my knee. So that's how tall my knee is. I'm pretty short. So I got that it's 1.55 feet. And so I said, okay, how many meters is that? Now, some students will say, oh, that's easy. You just divide by 3. There's 3 feet in a meter. That's not true. There's 3 feet in a yard. A meter is actually a little bit longer than a yard. There's actually 3.28 feet a meter. But you're going to have to use my conversions. So we're going to all do this with my conversions just because I can make you have to do that, right? I'm wanting you to learn how to do the conversion factors by doing more than one step. And I don't want you to just keep Googling all your answers. I want you to learn this format because it does help. Even those of you in engineering, I've had students who told me they had an engineering exam and they finished it in 2 minutes because they realized it was like a 3-page problem, and they did it as a factor label and did it in 2 minutes and turned it in and we're the only person in the class that got 100%, and everybody else was doing all this crazy stuff. But if it involves units, you can always do this. All right. Again, you can use parentheses if you prefer that. You're going to see me do these boxes. So I want to go from feet to meters. I'm going to use this conversion. So I want to change my feet to inches, pull the unit down, go to my new unit. So there's 12 inches in a foot. This holds true by itself. And then cross out the feet. I pull the inches down, and I can change to centimeters. So the 2.54 goes on top. The other thing that's really nice about those 4 conversions I give you between US and metric, the US unit always gets the number 1. So it's 1 inch, 1 quart, 1 pound, and then the number goes with the metric. We have one more step. and that is the centimeters we're going to change to meters. These, the 2.54 centimeters to an inch, that is a bridge between metric and US. And again, there's a multitude of bridges. There are, who knows, not an infinite number, but so many. What I'm doing is limiting your choices, because I have found in my experience, putting clear boundaries makes us more successful. It also allows us working together. If you're working together with another student, that you're able to see where you're going with it. All right, using the chart. If you want with centimeters to meters, and you're really good at metric, and you want to say, well, I know there's 100 centimeters in a meter, and you want to write it like that, I'm okay. That's how I often do it. I'm going to try and be consistent here and use the chart that I posted, because I found that the students who've always struggled with metric, the chart gives them a consistent way to do it. And it's that consistency and the practice that you all end up doing amazing, and everybody has an A+, and we're all happy. All right, so centimeters to meters. The 1 goes with the centi, and on the chart, centi is 10 to the negative 2. And that cancels. On this one, all the 1s are on the bottom, just happened, which is wonderful. So you just multiply across the top, 3 digits in our answer, 0.472. So on the video, this is again being videotaped. You can always stop me on the video and punch it in and make sure you can get my answer. And if you're not, with the math, it's really easiest for me to be able to verbalize and talk to you. So finding an office hour time that works for you. You can always send me an email and I can try to explain. The other thing I wanted to mention for my Chem 151 class, I am in class on Monday and Wednesday evening from like after 4 o'clock. I don't see my emails until Tuesday morning, and then we start Tuesday morning at 9 o'clock. And so sometimes I don't get to those emails until like late Tuesday or Thursday afternoon. So just realize I will get to it eventually, but sometimes just because of how my schedule is set up, I have to sleep sometime, which I do. And you should all sleep. Sleep is the most important thing. All right, questions? I'm going to erase and do the next one. Practice. This is what our, for those of you in Chem 151, the week 2 folder again opened today, and it has the notes for Tuesday. I made 2 separate sets of notes, one's for Tuesday and one's for Thursday. And the Tuesday notes are, we just do more and more of this. And then Thursday, we move into the periodic table. All right, we're going to look at a fairy flutters. Now, this is something for you, a warning. Start as far over as you can and find the piece of information you need. All right, so it tells us we have the fairy flutters, fluttering means flying, at 3.14159 meters per second. You want to write it as fractions. We're remodeling my room here to make it so I can teach, and so it's a mess right now. Only 1 unit per box. So I'm going to do something not correctly here. Don't do this, 3.14159, and write it as meters per second over this. You can't do that. It has to be 1 unit, and the per always means the other unit goes on the bottom. I recommend that you always write seconds as SEC, or else you're going to think it's a 5, and you're going to confuse yourself when you go to punch it in. Per means always 1, so per second means per 1 second. All right, where we are going is, I'm going to give myself more space. So on the paper, always start as far over to the left as you can. Don't get mad and frustrated at me and get upset that there's a fairy picture on there. Apparently there's a way you can delete her. I had a student one year who got really upset at my pictures. Don't do that. It's a fairy. Learn how to smile more. All right, the abbreviation for miles is MI. M is meters. So you have to write MI. We also want to write this as a fraction because this is all up and down, vertical, horizontal. And we're going to do this in one flow. So that's something I keep forgetting to mention. It says this at the top of the page. Factor label means we only do one flow. We only hit the equal sign on R at one time. So you're not breaking it into multiple steps. I'm going to first change meters to kilometers, and at the top of the page it says 1.61 kilometers equals 1 mile. So I'm going to use this. I'm going to change my meters to kilometers. So I ignore the seconds for now. It's there. I'll come back to it. I write meters, and I'm going to go to kilometers. And then I take this unit. So it's all about the units. My meters would cancel. I pull the unit down, and now I change that to miles. It takes practice. I recommend that today you go back and try this page again on your own. You don't have to print it again. You can just do it on notebook paper and try it without looking. And if you have trouble, you can go back and watch the video. Just watch, stop what I'm doing. My students who were really successful last year, because you'll see as we're going through chemistry, there's a lot of problem solving. When they watch the videos, they would stop me. They would always try the problem first, and then they would watch me solve the problem. When I'm videotaping, I don't give you that luxury. When I used to be in a real class, not in my like little itty bitty bedroom here, I always had that built in. I would do a problem, then I would, for the next problem, give you a chance to try it. So kind of just realize that for those of you who come to the lecture, which you all should. All right, that gets me to miles. So meters to kilometer, the 1 goes with the K. So the 1 always goes with the prefix. And then meters, in our handy dandy chart, kilometer means 10 to the third. So that goes there. On most of your calculators, you punch this in as 10 and the caret to the third. If your answers are coming out different with the metric, it has to do with your calculator. This is how I recommend, if you have this key, you can also put it in as 1 and then the exponent key, which would be the E to the third. This E means those 2 keys. I mention this because there are some students who will punch it in as 10E3. And if you do that, you're doing the 10 and you're doing the 10 again. And so you're always off by 10. So just be careful. It's this way or this way. Don't combine them. And then my kilometers will cancel. US gets the 1, 1.61 kilometers. All right, we're not done. We got to miles. We're halfway done. So that's good. Celebrate that. I'll do a happy gnome dance. Now what I have to do is change my seconds to hours, and I'm not going to break this into steps. And I am totally aware there's other ways to do that, but we're learning this for a reason. So this is practicing. This unit is down here in the denominator. We're now going to move it to the numerator. So we pull the seconds to the top. And you could go straight to hours. You'll see me do that sometimes. I'm going to go to minutes. There are 60 seconds in 1 minute. I like to cancel units. I recommend, again, it's a recommendation that you always cancel your units. The students who do that actually do better because they don't get lost. Now I'm here with minutes. So since it's in the denominator, I pull it up and I go to hours. 60 minutes in 1 hour. My minutes cancel. The only units I have left are miles on top and hours on the bottom. So we did it. It takes practice. You can do this thing where you skip from seconds from there to over to here. And you can do that because multiplying and dividing, the seconds, it doesn't matter the order that we do the steps in. What matters is that you multiply across the top and you divide on the bottom so that the 60s end up on the top. You would punch this in. Again, how I would punch it in my calculator, I start here, I ignore all the ones. So I start 3.14159, I divide by 10 to the third, I divide again by 1.61, I multiply by 60, I multiply by 60. So I don't use parentheses at all. 3 Sig Figs again. So our answer is 7.02 miles per hour. When you write your answer, you can use the slash. When you're doing the factor label, you don't use slashes. All right. Got one more. Questions? I sure hope this is videotaping, not how I'm seeing it. I don't want to do this a third time. All right, we're gonna do Airy Berry Fitzferry. And I'm gonna move down here so I don't have to keep erasing. I'm hoping you can see me down here. If it gets blurry or something, tell me. There's 2 pieces of information with this problem. So we have a 333-pound troll and 1.618 milligrams per kilogram. All right. So this is the dose. What happened to I had a really good pen last night. Let's see if this one works. So this is the dose. Look at that. This is always the dose per body weight. That's a lot to write. Our bodies are large. Our bodies are not as large as a troll, hopefully, but our bodies are talked about in kilograms of body weight. Drugs are always, they're toxins. That's why they work as drugs. We're trying to kill something. This is fluffernutter, by the way. Fluffernutter is a mix of peanut butter and marshmallows, and it probably would kill you in small amounts. But dose is always in small, like milli or micro. If it's like chemotherapy, it's also nanograms and picograms and even femtograms, because just a small amount will be very toxic. All right, one of the things with dosage is you never flip upside down. So just make a note to yourself, you never turn it upside down. It always stays how it is. The other hint that I'm going to tell you, and you're going to see this as we do more practice, when you have 2 pieces of information, I am not in here when we're just learning this, give you extra information. So when you have multiple pieces of information, underline it, like get a colored pen and underline all the information. Find the piece that has 1 unit and start with the 1 unit, meaning it's just pounds. The troll is extra information. So we're going to start there. And what we're solving for, I think, is grams of fluffernutter. Yeah. So this is pounds of the troll. You can draw a troll if you want. And this is grams of fluffer. Okay, this is really weird. This morning, I went on my email, and my top email, their name was actually Fluffer. The email address was Fluffer. I asked them why that was their email, but I thought that was really weird. And this is another weird fact. Fluffernutter, which again is this toxic mix of marshmallows and peanut butter. My birthday is actually National Fluffernutter Day. And everybody's birthday is a national day. And so that's my claim to fame. So that's why Fluffernutter shows up in this question. So you can Google when my birthday is. It's coming up really soon. So we will get to that eventually. All right. We use that piece of information. So some students will lightly cross things out as they use them. If you cross stuff out, use something that you can erase in case you make a mistake. We're going to change pounds to kilograms. Now, there is a way you can do it in one step. People who've worked as medics, they know there's 2.2 pounds to a kilogram. I didn't give you that conversion. So again, we're going to use the US Symmetric Conversions that I gave you. I gave you pounds to grams, and then we're going to change our grams to kilograms. Because we're learning this methodology, so when we use the periodic table. So bear with me. Pounds cancels. My conversions are awesome because it's always 1 US to whatever number of metric. The other thing is mine always have 3 Sig Figs. So our answers will pretty much have 3 Sig Figs. The exception is if I started you, if our troll was only 33 pounds, so it was a little troll, then you might be limited to 2 Sig Figs. All right, kilo gets the 1, 10 to the third. You can write it as 1,000 if you prefer. Sometimes I end up doing that. And now the dose comes in. Always the dose is on top over the kilogram. Some students have trouble with the dosage problems because it's a mass over a mass. So a couple of you, like Christian's going to go into pharmacy. You do dosing a lot. There's somebody who's going into nursing or the medical field. You guys do dosing. All right, we're at milligrams. So now we just change our milligrams to grams. Milli gets the 1 using my chart. And milli is not 1,000, it's 1,000th. So 10 to the -3. And my units all canceled, and I'm at grams, and I punch it in. And if you can't see my answer, let me know. You can hear it. It's 0.245 grams. 3 Sig Figs. A reminder, Tinkerbell talks about this. I often leave the 0 off. It's just a habit. You have to show the decimal. If you're going into pharmacy or nursing, always show the 0 because they will mark you wrong. A comment about this page in scientific notation, I would never put any of these numbers into scientific notation because the importance of scientific notation, I think Tinkerbell talked about this, is when you're dealing with really big and really little numbers. None of these numbers are really big or really little. When you start having 4 zeros, you definitely want to use scientific notation. So when it's hard to see how many zeros there are, we're going to deal with huge numbers when you watch the thing on atomic history. All right, are there questions? All right, I am going to switch and share my screen actually. And we're going to do the last page. So that was this page. And again, I don't think anybody in this class had asked, but it is really helpful to print your notes, but you can always do it on notebook paper and realize you can then watch the videos to fill in the gaps. I mentioned this the first class, you'll hear me mention it again. My students who were really successful last term, they would go back and watch the videos. They would attend, the most successful ones would attend, my gnome hat is, they would attend both the lecture and go back and watch the videos. You're all gonna have a day where you can't come to the lecture, and I know some people work. So that was going through this page. We're going to, for those of you, you're in 151. My video last night messed up, and so I'm gonna clip this part and put it in my 104. But our lecture on Tuesday is 2 more pages of these. And so you're gonna become really good at this. This is not on your study set 1, what I just did. This is not on your quiz 1. This is study set 2, which is not until week 3. So I'm going to be going over this on Tuesday. There's 2 whole pages, like 12 questions I'm going to go through. Your lab 2, which is next Thursday, is this stuff again. The lab is meant that you can come to my office hours, or if our lecture only lasts, like we'll get done with lecture early, you can stay and work on the lab and ask me questions. And there's a really cool feature. Christian was here early, and so he got to use the feature, which is a screen share, which I'm doing, but I enable it so you can share your screen. So I can look at what you're doing on this screen like this and give you feedback so that you can do better. This page is already videotaped. So please, if you're not sure how to find my YouTube videos, you do want to go on it. You go onto Blackboard, you click on my YouTube link, and it will take you there and you'll see Tinkerbell. There's actually another video of Tinkerbell now of her doing density. Those notes are for Tuesday. It's a pre-lecture. So if you can get your Tuesday notes, it's the first page of the notes. I'm going to assume that you will watch that before the lecture. You definitely have to watch it by next Thursday. It's going to be a beautiful weekend, but the smoke from California is kind of taken away from that. I'm going to now go through the last page of our notes, which is, it's always, you can still see that. Maybe it was better closer. We'll go close. All right. And again, if you didn't print, it can be helpful, but just take notes. You can just write down what the final answer is. Oh, this was a question somebody asked me today. They said they don't have printer paper to print the study set and stuff. You can do it on you can do it on notebook paper, and then you just take a picture and upload it. The study set is for you. You just upload that and you get 5 points. This, what we've done so far, what we did on Tuesday, this page, what I did, Tinkerbell's page, these are notes. You don't turn these in. These I go over, they're for you so you can organize your stuff. Yeah, so this is just practice. This is not worth any points. It even tells you that at the top. It's worth 0. It is really great practice though. Great's a big word. All right, we're looking at, this is going back to chemical and physical. Again, that stuff is the next week we come back to it. So a reminder, most things are physical. Physical is anything you can measure. So all that stuff we were just doing, and anything you can sense. So color, odor, those are physical. Melting point, changes in states of matter. So states of matter, which is solid, liquid, or gas. Those are physical. So most things are physical. I'm just going to mark the chemical ones. D is chemical. So there are some vocabulary words. I mean, you guys can always Google. Combustible means to burn. You have heard this word before. They often refer to us as the combustion age, and that is because our bodies are combustion engines. We are actually moving, which is really cool. Most people don't realize we're moving into it. We're moving into the magnetic age. And so they're on the verge of realizing that magnets are actually the answer because of their pull and repelling. And so it's all changing fast now, but magnetic and metallic are physical properties. So the fact that a certain element will stick to your refrigerator, the only elements that are ferromagnetic, the magnetism that iron has, is iron. Actually, there's my periodic table. Iron, cobalt, nickel will all stick to your refrigerator. And so it's a special thing about those 3. Something also really cool, because this gets into nutrition and health, vitamin B12 is cobalt is in the middle holding it together, and they believe it's the magnetism of that cobalt. It is needed to keep your blood healthy. iron is in the middle of your red blood cells, and it is believed it is actually the cobalt magnetism in the B12 that magnetizes the iron, that attracts the oxygen that we breathe in and allows your red blood cells to deliver it. That's actually all based off of magnetism. I read an article about that 25 years ago, and I'm amazed it's still, nobody talks about it, but it makes a lot of sense. So I'm teaching you all about the physical world, and I think we're looking at it wrong, but I love when we get to quantum mechanics. All right, so in that first column, combustible was the only chemical. The others would all be P's. Ain't got no homework. I have you just find the chemical ones. All right, in the next column, it's a solid, physical. Dissolving is physical. There's no chemical change happening. All right, here, heating in air means, again, that you're burning. In the air, we have nitrogen and oxygen. It is the oxygen that reacts. Nitrogen has a triple bond, so it needs like an electrical storm. It needs a lot of energy to have it react. And so that's what happens when lightning strikes, is the nitrogen becomes available. And certain plant roots also. All right, the snowball disappears just means it melted. Sand is separated. Filtration is a physical separation. L, resting. Oh, that again means oxygen is reacting. So you may notice a theme that's been happening here. Oxygen is the second most reactive element on the periodic table. It's extremely greedy. It wants electrons. We're going to get into that over the next 2 months. But rust means it reacted with oxygen. It can react, other things react too, but oxygen is what drives our life. That's why we are combustion engines. So only 3 of them were chemical. I just circled the chemicals, sorry. All right, the next question. I actually got this, inherited this page 25 years ago from a coworker. And there are some things I'm going to point out that I try to avoid. We're just going to say if it's a mixture or a pure substance. There are, if you remember from the lecture on Tuesday, there are 2 types of pure substances, and they are compounds and elements. That was my brain slowly finding its place. Pure substances are always homogeneous. Homogeneous means it looks the same. Again, this is looking with our eyes, and the prefix hetero, can't remember if it's Greek or Latin, means different. So a chocolate chip cookie looks different when you look at it. Oxygen is an element. It's on the periodic table. So you can call it, it's a pure substance. If it's on the periodic table, it's an element. Elements cannot be chemically changed. They're on the periodic table. So B is a mixture. This pure is, I don't know, you know, that's an advertising thing. It has sugar, it has water, it has, maybe it has vitamins. They're trying to say, oh, this is from Mother Nature. We didn't make it by man, but we did. We processed it to get rid of the fiber. This usually is homogeneous. I'm going to write it as HM, just for space. I asked this question actually one year on a quiz, and half the people said homogeneous mixture, and half the people said heterogeneous mixture. And I said, why are they all thinking it's heterogeneous? So I made my husband, Joey was a baby, just 20 years ago, take me to Safeway at 11 o'clock at night, because I was kind of mad at my class for getting it wrong. And sure enough, I stared at the apple juice on the shelf, and half of it was heterogeneous. Half of it had floaties. So heterogeneous means you can see the floaties. I try to make it a question where you don't have this problem. Same with C. C is a terrible question. What type of water? Are we talking pure water? I would always say it's tap water. Tap water would be a mixture. Bottled water is a mixture. If it's a pure substance, I would probably write it as H2O. So when you see the symbols, you would say, oh, that's a compound. Again, if it was bottled water or tap water, that would be a mixture. So if you see symbols, different types of symbols, H's and O's, it's a compound. Just a reminder, I don't remember if I told you guys in 151, this is why on your lab you have the periodic table elements. Start becoming familiar with them. You're always going to be able to have a periodic table with names, but being familiar makes communication better. So when I'm talking about hydrogen and oxygen, you're like, oh, those are just elements. Right, D is a compound, because you see symbols, nitrogen and hydrogen. You don't need to know the names of compounds yet. That shows up in the 5th week. All right, the key here is the word solution. Solution means it is mixed with water. Solution always means a homogeneous mixture. So it means it's with water. And then air is always a mixture. The word unpolluted is trying to imply it's homogeneous. Our air today is not homogeneous. Our air 2 weeks ago when they canceled college, when we had all the smoke, pretty interesting. That would have been heterogeneous. On the homework, again, the first page has more of this. All right. And then your quiz will be a much smaller version of this. And the quiz, again, will appear on Tuesday, and it will be due by midnight. You'll just do it on your own time. That will save me time in class. So we'll go through the homework, and then I'll do like an hour-ish lecture, and those notes, again, are posted. Oxygen is an element. Water is a compound. Nitrogen is an element. It is only made up of one type, nitrogen, and two. Two is just there's always two of them together. All right. D, that is carbon monoxide. This is a compound. The second one is an element. And my question, does anybody know what element that is? It's a capital C and little case O. Go ahead.
Cobalt.
It is cobalt. Yeah, you should all start learning those. So Christian, I'll give you a bonus point if you get this. You know the symbol for copper, because that is not copper.
Wait, what did you say?
What is the elemental symbol for copper?
Cu.
It is. So cobalt, this is actually really cool. Cobalt means gremlin. I couldn't make this up as a gnome if I wanted to. And the copper miners, cobalt and copper are always found together. And the copper miners were getting frustrated because they kept getting, and they called it a gremlin. And so the word in German for gremlin is cobalt, and that's how it got its name. It's also a good reminder. You guys get to write a brief paper about one of the elements. And so, yeah, and that's not until the last week. And then we do, it will be fun. All right, and then the last one is a compound. Oh, we get to do math here. So we're going to do a review of Sig Figs. If you haven't watched Tinkerbell, please do. But Sig Figs are, I'll fill in, this might also help if you had a question. Zeros, it has to do with that zero. Zero to the right, if it's on the right of a non-zero, it is significant. And so this zero is significant. So all 5 of these digits are significant. This one, again, if you have a decimal, it is significant. It's telling you how precise your measurement is. So the 12.000, all those zeros are significant. Zeros in between, the non-zero, sorry, I'm just abbreviating, they are always significant. You don't have 22, you have 2002. So 22 centimeters is very different from 2002 centimeters. So that has 4 sig figs. The no for the zeros is zeros on the left of the non-zero. So again, we're not looking at the decimal, we're looking at the non-zero, meaning the digits 1, 2, 3, 4, 5, 6, 7, 8, 9. So this has only 2 sig figs, just the 2 and the 0. Scientific notation gets rid of those zeros. They are important. They are placeholders. They are not significant. All right, I don't have my answer key, so I'm going to punch this in. Reminder, you need to, I just take this number, divide, 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 or you have to divide by all of them. So some of you, if you're getting the wrong answer, it's that you need an extra set of parentheses. So when you multiply or divide, you use the least number of sig figs. So this is the video Tinkerbell goes through, condensed into under 5 minutes, hopefully. So our answer is 0.044. I'm going to change it to scientific notation in a moment, but we'll leave it like this for now. Units. You have to have units. Sig figs, you have to have a number, you have to respect sig figs, and you need to show units. None of my units cancel. I end up with grams over centimeters cubed. It is mass per volume. Cubic centimeters is a volume. That's the video for the first page of notes for Tuesday. I put it up today. It's another Tinkerbell video. It's hard for me to take this whole situation we're in too seriously, so you should all have fun. Let me do it down here. Or no, let's do the next one, sig figs. Again, decimal is there. All the zeros are significant. So we have 4, we have 5, we have 7. If there is a decimal, the zeros are significant. And then we add it up on our calculator. So your calculator will give you this answer. When you add or subtract, they have to be the same unit. So this will be grams. That was my answer up there. So when you add or subtract, oh, I do have other colors. When you add or subtract, you look at the place value. So this went 3 decimal places. This goes 2 decimal places. This goes 3 decimal places. My answer needs to go 2 decimal places. So it is the shortest place value. It's an interesting rule, but it is important. We use the multiplying, dividing all the time. The adding, subtracting isn't used as much, but it's important. Since there was no digit there, you just add the 0. That's the correct answer. My answer actually ends up with 6 sig figs. When you multiply or divide, it's the least number. When you add and subtract, it's the place value. All right, we're going to change it to scientific notation. So the first one is 4.4 times 10 to the negative 2. The unit goes after the scientific notation. Scientific notation is 1 non-zero to the left of the decimal. You lose those zeros. If I change this one, 1.85130, you keep, I didn't round it. Nope, didn't want me to round. Times 10 to the third. So my decimal moves 1, 2, 3. I don't do well with lefts and rights because of the weird mirroring thing so that everything doesn't end up backwards. And it's just grams. If I had asked you to round to 2 sig figs, so this number with 2 sig figs is my question, it becomes 1.9 times 10 to the third grams. So the 5 will make the 8 round up. There's some questions I think in the homework about rounding. And again, when I get done in a couple moments, you can stay after if you have questions. All right. So this is just some algebra. To solve, use pink. We would multiply by the 5.15 milliliters, so it cancels. This is per milliliter, so this means this is grams over milliliters. So the milliliters cancel. We would multiply right. So you have to round to 3 sig figs, so 8.76, and it's just grams. So since both pieces had 3 sig figs, we're going to keep 3 sig figs. So you can say Q equals 8.76. All right, on the next one, since we're subtracting to move it, you would add to both sides. That would cancel. So my Q is 9.36. I know your calculator gives you, if you do it on the calculator, 9.361, but it is place value. We can only go 2 decimal places. So the correct answer with the correct sig figs and the correct unit would be 9.36. Any questions?
Wait, why is B 9.36?
You lose the 1 because it's this rule here. When you add or subtract, you look at the shortest place value. So you can only go, the 9.25 only goes 2 decimal places. So my answer only goes 2 decimal places.
Okay, that makes sense.
Okay. Anybody else questions? I do want to put this out there also. If you want me to scan and put my notes up there, I can. I probably will forget to do that, but I can. I think most of you've got it. And you can also go back and watch the video. I'm going to stop recording.